Hello students, good morning, good evening and good night, depending on which time we are going to observe this lecture. Welcome to the 7th lecture on alcohol, phenol and ether chapter. In this lecture we are going to discuss again a very important thing in this chapter, that is your properties of the phenols, in which we will discuss about the electrophilic substitution reactions. In the previous lecture we have discussed about the reaction concerned with the hydroxyl group present in the benzene ring in the phenol compound. The reaction occurred at the benzene ring is called the electrophilic substitution reactions. Due to the presence of the OH group in the phenol in the benzene ring, the benzene ring is further being activated towards the electrophilic substitution, because benzene itself has a very electron rich species, and when we add OH group, there is a transfer of electron from the oxygen of the OH group to the benzene ring. So it further activates it and it is become a higher source of free electrons. So in this way that it is going to activate the benzene ring and towards the electrophilic substitution reaction. And the incoming group that we will understand, that is basically ortho-directing in para-direct. So heading of this today's lecture is the electrophilic substitution reaction. So we will going to discuss different reaction has been occurred in the benzene ring in the phenol, that is the electrophilic substitution reaction. Now we first understand in the electrophilic substitution reaction why the incoming group will join to the ortho position and the para position, and that can be easily been understood from the resonating structure of the phenol. So this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. First, let us understand the resonating structures of the phenols. So these are the resonating structure of the phenol, that you can easily understand one thing very clear, that in this position, that is in the ortho positions and in the ortho positions and in the para position, the electron density is much more than any other position. So when there is a electrophile is coming to attack this benzene ring, then it will be attached at this position where there is a higher electron density. So that is why this OH group is basically, you can see that it is ortho and para directing. This is ortho or para directing. O means ortho, P means para. So now we understand that benzene ring in the phenol is much more activated due to this OH group, because OH group donates the electrons to the benzene ring and it will become a higher source of electrons, and it will easily attract any electrophile towards itself in the specific positions, that is ortho positions and para positions. Now we are going to discuss different reaction that is in your syllabus, and that is we will understand with some mechanisms also. The first reaction that we understand, that is halogenation reaction. Halogenation reaction. towards this electrophilic substitution reaction. So in this case you do not need any Lewis acid. So we can understand the Lewis acid is not required in case of halogenation for the phenol. Lewis acid is not required for this. Lewis acid not required for this halogenation reaction. Okay, because the benzene ring, due to the presence of the OH group, it is much more activated. The first reaction in the halogenation, that is we will discuss, that is OH with bromine water. With bromine water you will see that it will going to produce this compound, this is 2,4,6 tribromophenol. This compound is going to be produced and it is having the white precipitation. You can observe the white precipitation. White PPT will be there, and it is one of the identified factor for the OH group. This reaction is not been occurred, this is not been shown by the alcohol. So this is one reaction. In case of bromine water, it will produce this 2,4,6 tribromophenol and it is having the white precipitation. And another reaction, that is a phenol, when we change the solvent, that is here solvent is highly polar, H2 is highly polar solvent. If we change the solvent at that time, what will going to happen? Let us understand. When carbon disulfide is a solvent, at that time the product will be different. Product will be, that is the mixture of product we will find. One, that is the orthobromophenol and another is parabromophenols. In this product, this is the major product, parabromophenols is the major product, whereas the orthobromophenol is the minor product. Or we can say this is a 2-bromophenol, or this is also the 4-bromophenol, or otherwise you can another name, that is orthobromophenol and parabromophenols. So this is the halogenation reaction, and in the halogenation reaction we do not require any Lewis acid because of the fact of the very high reactiveness of the OH group, and it will easily polarize the halogen. Okay, so this is the first reaction. The second reaction that was going nation. Sulfonation reaction, that is the incorporation of the SO3H group in the benzene ring. So this reaction also you observe with the different condition, the product will be different. As for example, when the phenol has been reacted at the lower temperature, that is 288 Kelvin, with the H2SO4. With H2SO4, it will going to produce orthophenol sulfonic acid. This is orthophenol sulfonic acid. Orthophenol sulfonic acid. When this phenol is reacted at the higher temperature, that is 373 Kelvin, with H2SO4, it will going to produce the another product, that is called this product will be formed. It is SO3H. This is paraphenol sulfonic acid. So these two products we will find for the sulfonation. Next reaction that we are going to discuss, that is the nitration. In the nitration, it is basically the incorporation of NO2 group in the benzene ring. Nitration also occurred, and different type of product you can observe. That is, in the dilute nitric acid you will find something, and when it is a concentrated sulfuric acid, mixture of the sulfuric acid and nitric acid, you will find something, and when it is been in the different ways that we are going to observe here, that is nitration when the phenol, this is phenol, and this phenol with the dilute HNO3, at the time you will observe the mixture of product, that is the orthonitrophenol. This is orthonitrophenol, and another product that is going to be produced, that is the paranitrophenol. So orthonitrophenol and paranitrophenol we will observe. Here this orthonitrophenol is the major product, whereas the paranitrophenol is the minor product. But when this has been reacted with concentrated H2SO4 and HNO3, at that time it will going to produce this product. This is NO2 and this NO2. This is 2,4,6 trinitrophenol, and it is called also the picric acid. But in this way, when we going to produce the picric acid, this yield is very much less. For that, what we have to do, first we have to, in the several ways, that is ways that we can able to make this nitration, that first this phenol will be react with the concentrated H2SO4, and this, when you react with the concentrated H2SO4, it is going to produce this SO3H, OH, and this. This is 2,4 phenol 2,4 disulfonic acid. This is phenol 2,4 disulfonic acid, and when this is react with the concentrated HNO3, it will going to produce the picric acid. It is going to produce the picric acid. So first we will concentrated H2SO4, reaction will be, and in this case this product will be there, and after this the concentrated HNO3 with concentrated HNO3 you can able to produce this picric acid. So this is the nitration. Now we are going to discuss another very important reaction, Friedel-Crafts reaction. In this reaction that we can see that the phenol has been reacted with the methyl chloride or in some alkyl chloride in presence of aluminum, anhydrous aluminum chloride. So this reaction will be like this. This is the phenol, and it will react with the CH3Cl methyl chloride in presence of anhydrous LCl3. LCl3 here acts as a Lewis acid, and it will going to produce a mixture of the compound, that is CH3 group in the ortho position and in the CH3 group in the para position. This is called the orthocresol. This is orthocresol and this is paracresol. So mixture of the compound that we observe here to produce. This is a Friedel-Crafts reaction. It is been occurred in presence of the anhydrous LCl3 Lewis acid. Now the next reaction, that is the name reaction, that is that we have discussed so far. First, that is the halogenic reaction, second sulfonation, third nitration, and fourth we have discussed the Friedel-Crafts reactions. Fifth, that is the name reaction, that is Kolbe reaction. Kolbe reaction. In the Kolbe reaction, it is a very important reaction that we can observe, that this is the reaction where we produce a very important compound, organic compound, that is called the salicylic acid. Salicylic acid is a source of many other derivatives, which has a lot of application in case of medicine, that we can use this in case of another applications also, that we will also going to discuss. In this Kolbe reaction, what is going to happen? The reaction is like this. First, the phenol is react with NaOH, and this is produce the phenoxide ion, sodium phenoxide. This is going to produce the sodium phenoxide, and this phenoxide ion is very much reactive. It is so reactive, it will act with the carbon dioxide. It is a very weak electrophile, and it will going to produce this compound. It is the sodium salicylate. It will going to produce the sodium salicylate. Sodium salicylate. And this sodium salicylate, when it is hydrolyzed in presence of the dilute HCl, it is going to produce the salicylic acid. It is going to produce the very important compound that is called the salicylic acid, or we can say name of this compound is 2-hydroxybenzoic acid. This is also called 2-hydroxybenzoic acid. Salicylic acid or benzoic acid. 2-hydroxybenzoic acid. And this is the product, that is salicylic acid, that has a lot of application that we will be able to discuss now. What are the application of this salicylic acid? There is a lot of application that we can understand from this discussion. That salicylic acid has been there is a lot of applications in different areas when this salicylic acid is react with the acid anhydride, and in presence of H2SO4, it will going to produce this they are going to produce this. This is aspirin. This is aspirin that has been used for many medicines, that is for lowering the temperature, body temperature, and it is other applications also. You can see this is aspirin, and this name of this compound also, this is 2-acetoxy-benzoic acid. Acetoxy-benzoic acid. Another application, when we will react with the phenol, salicylic acid, when we react with the phenol, it is going to produce another compound, a very important compound, that is COC6H5. This is called salol. This salol is used for many antiseptic things, intestinal problems, intestinal, when there is an infection, at that time this has been used. This is called salol. And another thing, when this is react with methyl alcohol, it is going to produce another product, that is a very important product, that is going to understand. This is COOCH3, that is methyl salicylate, name of the methyl salicylate, and it is called the oil of wintergreen. Oil of wintergreen. That has been used in flavoring, creating the flavor in the toothpaste, creating the flavor in case of other perfumes. That is a very wide applications. Okay, so we understand the Kolbe reaction and how the salicylic acid has been used in the different applications in our day-to-day life. Now there is the sixth reaction that we are going to discuss, that is the Reimer-Tiemann reaction. Reimer-Tiemann reaction. In this reaction, we will go, the phenol has been reacted with chloroform in presence of NOH, and it is going to produce a intermediate. This is a intermediate ONA plus CaCl2. This intermediate is called benzyl chloride, and when this is been react again with NOH and it is further hydrolysis is done, at that time we will found to produce this product, that is the salicylaldehyde. This is salicylaldehyde. This is the salicylaldehyde. So next is a very important in this reaction, that is phenol has been react with a benzene diazonium chloride and in presence of the very weak alkaline condition, and it is going to produce the azo compound, the benzene diazonium salt. This is benzene diazonium chloride. And this is the phenol. Here the hydrogen of atom of this phenol has been replaced by this reaction between this chlorine atom and the hydrogen atom, and it is going to create This is 4-hydroxy azobenzene, and this is called the azodiaz also. There is a formation of the color compound, the orange color compound you will found this way. This is called the 4-hydroxy azobenzene, and this is called the coupling reaction, and it is occurred in a very weak alkaline conditions. The last reaction that we are going to discuss, the oxidation reaction. Oxidation, this is called the L-7 peroxide persulfate. L-7 persulfate oxidation. In this reaction, what we observe, the phenol has been converted into the dihydric phenols. When this is being oxidized in alkaline medium, that is potassium persulfate, and in presence of KOH, it is going to produce the dihydric alcohol, dihydric phenol, that is this. And this is, and there is some amount of the catechol you can able to see. This is the catechol, and this is hydroquinone, or it is called the hydroquinone. So when this is the oxidation reaction, and it is called the L-persulfate oxidation, when the phenol has been reacted with in presence of the potassium persulfate, in presence of KOH, it will going to produce this hydroquinone. So this is all for today's lecture. In this lecture we have discussed about the electrophilic substitution reactions. That is, first we have discussed the halogen reactions, halogenation reactions. Then we have discussed the sulfonations, nitrations. Then we have discussed about the Friedel-Crafts reaction, Kolbe reactions, Riemann-Triebel reactions, and last two reactions, that is coupling reaction and another, that is the persulfate, L-persulfate oxidation reaction that we have discussed. So that is all for today's lecture. In the next lecture we will discuss about the preparation of the ether and its physical and chemical properties. If you like this lecture, you can share to your friends. Thank you.